Hi, folks. This is meteorologist Don Paul with my newest chapter here on Don Paul Blathers, which is always the operative verb for me, if you know my work. And I want to take a little time this time around to acquaint you with one of my favorite sources for climate information that is essentially unimpeachable. It is climate information written for the layperson by world class climate scientists at NASA in very many scientific disciplines. It's all peer reviewed, evidence based science. And this site is found at climate.nasa.gov. That's climate.nasa.gov. But if you think you'll have trouble remembering a web address, all you have to do is search engine the phrase NASA climate, and it will take you to this site. And I want to counter some of the myths which prevail among those who either don't know anything at all about these topics or those who are politically active in trying to oppose this peer reviewed evidence about how we know climate change is occurring and how it is related to human activity is partly complex, but parts of it are simple. This is a graph over the last 400,000 years of CO2 levels, and you might quickly ask, well, how do we know what CO2 levels were 400,000 years ago? Well, there are ice cores that have been dug up by paleoclimatologists, and there are bubbles of the atmosphere from that time trapped in the ice. And the bubbles reveal how many parts per million was in the air, or were in the air, of CO2 and methane and water vapor and other gases. And you can see over the 400,000 year period, the peak periods, which were all associated with warming periods around the globe, never got above 300 parts per million until now, in the last few decades. And since then, there's been a more than 40% increase in the amount of CO2 in the atmosphere. CO2 may be a small amount of the gas that's in the atmosphere, but it is a strong greenhouse gas. It has a long shelf life in the atmosphere. Once it goes up there, if it's not metabolized by plant life, CO2 molecules can stay up for more than 1,000 years in the atmosphere, and we're producing more and more of it. In fact, just this week at the Mauna Loa Observatory in Hawaii, a level of 415 parts per million has been found, and that is the highest level in more than 800,000 years. This graph only shows 400,000 years. The scientific evidence for warming of the climate system is unequivocal. I know of one meteorologist who's a brilliant meteorologist but has some highly politicized views on climate change, unfortunately, who, while he denies his belief that we're causing most of it, he is fully in agreement that the globe is warming. And it is warming fastest in the Arctic, which was actually predicted fairly easily in the climate models of the 1980s. The global temperature rise since the Industrial Revolution really got into high gear around 1880 has gone up about 1.6 to 1.7 degrees Celsius, Fahrenheit. That may not sound like much, but it's been enough to cause the rising sea levels. And the oceans, in the meantime, have absorbed 90% of this excess heat. And you may say, well, that's a good thing. No, it isn't, because the extra carbon and the heat that the ocean has absorbed is killing coral reefs around the world. And also, it is changing the nature of ocean temperatures to the point where the water is rising, not just to glaciers melting and the Greenland ice cap melting and Antarctica peripheral ice melting, but also because water expands in volume as it heats up. In other words, the warmer it gets, the more water is out there and the sea levels rise. They don't rise uniformly at every location in the globe. Some areas get more than others in the way of sea level rise. Ice sheets are shrinking. In fact, Greenland has been losing an average each year since 1993 of 286 billion tons of ice. And Antarctica has been losing 127 billion tons of ice per year during that period. but the rate of Antarctica ice mass loss has tripled in the last decade. This is measured with precision by satellite imagery as well as surface instruments. This is not just guesswork. So, most of the glaciers on the globe are in retreat. There are a few exceptions. One very large glacier on Greenland has slowed down in its retreat in the last 2 years, which is a good thing. It's temporary, though, and it's due to cold waters upwelling near the edge of that glacier in the North Atlantic, keeping the water around the glacier much colder and slowing down the melt rate. But the rest of the glacial ice mass on Greenland, it's not linear, it's not the same amount every year, but it is basically losing ice pretty quickly, even with some increased snowfall from time to time. Snow cover around the northern hemisphere has decreased over the past 5 decades. Snow is melting earlier over the last 5 decades. And I dare to do this during what has been a rotten spring across the Great Lakes in the Northeast, but we never confuse weather, short term weather phenomena, with climate and climate change. By the way, I personally am not a fan of the phrase climate change. It should be mean global warming. Yes, the climate changes in varying degrees most times in the Earth's history. Most of the big glacial advances and retreats until humans came along were caused by eccentricities in the Earth's orbit, which would change the amount of solar energy the Earth would be receiving over 1,000 years. But this rise in temperatures is due to us, and the evidence is unequivocal because if you remove the excess CO2 that we've put out there, the total amount of solar irradiance reaching the Earth in the last 40 years has actually decreased slightly. There's a huge oscillation in the Pacific called the Pacific Decadal Oscillation. It has been in a cold phase most of the time. Both of those two put together mean the world would have been cooling during the last century were it not for us people. We are doing it, and we're doing it with CO2. We've also helped nature and agriculture to release a lot more methane, which is a very strong greenhouse gas. And then when you get the warming from CO2 and methane, there's more evaporation of water vapor from lakes and especially the oceans. That's a greenhouse gas, and there's 7% more water vapor in the atmosphere on a daily basis now than there was in the 1950s. So that also, along with CO2 and methane, traps long wave radiation and keeps it from going back into space like it typically would. So Arctic sea ice definitely on the decline. It's not the same amount every year, but in fact, it has been on the decline for several decades and drastically. And when you go from highly reflective white ice and snow, which sends a lot of the solar energy back into space, to dark blue water that absorbs the heat energy, then that water warms up, evaporates more water vapor into the atmosphere, and you have a shorter freeze season during the winter. The ice stays melted longer, has a shorter time to refreeze, and when it does refreeze, it's thinner than it used to be and then melts more readily the following season, so you get this feedback mechanism. So that's just a touch of what we're seeing in the way of evidence. And there is on this climate.nasa.gov website also great information on what it is we don't know. This is not a site that is a propaganda mill. It is staffed by NASA scientists, and NASA affords you a great look back at a history of droughts, whether or not they're increasing in coverage. Right now, the lower 48 states are in the best shape in terms of drought coverage that we've been in 5 years. And a lot of the very severe drought, which had been occurring in California and the West, has receded for the time being. But overall, in recent decades, globally, we never look only at our continent. Coverage and severity of droughts is increasing. Antarctica's effect on sea level rise in coming centuries is going to be increasing. Warmer ocean waters are melting a lot of the ice around the edge of that vast continent, and then that allows the ice over the land of Antarctica to melt and flow toward the oceans increasing the sea level rise. And there are some ideas on this site for solution, mitigation, for example, to lessen the impacts to some extent of the rising sea levels. For example, I have an article in the Buffalo News right now about what are called sunny day floods, flooding which occurs at high astronomical tides more often along the East Coast, the Floridian coast, parts of the Pacific coast, and other continents as well. Well, the city of Miami Beach is spending $500 million to raise the street and land level from its current 5 feet above sea level to 7 feet above sea level. An enormous expense, but it may prolong that city as a tourism and residential mecca for a few extra decades before the inevitable additional sea rises overtake human efforts. Former Mayor Bloomberg has proposed building extremely expensive floodgates to protect New York City and the New York metro area from storm surges and the rising sea levels. Very expensive, but to just give in and allow the oceans to encroach into Wall Street, which is the financial capital of the world, not just the United States, as well as residential areas. The costs of not doing that so vastly outweigh the very high costs of building structures to at least postpone the impacts of these rising sea levels, which globally are averaging about 3.3 millimeters per year. In some parts of the globe, the sea level rise is much more rapid. There are a few small spots where it's hardly rising at all due to cold waters coming up from the bottom of the ocean, and that really keeps the water colder and doesn't allow it to expand as much. So while NASA is our space agency, NASA is also doing a lot of the work along with NOAA, the National Oceanic and Atmospheric Administration, to study what is happening, what is most likely to happen, and also what are the different scenarios. There is simply no question whatsoever that sea levels will continue to rise into the next century. The real uncertainty is whether or not we will have a best case scenario, a mid range scenario, or a worst case scenario. How much will the sea level rise be? And there's still not that much agreement. NASA tries to aim more toward a mid range scenario, but that doesn't mean that's going to work out very well because we are seeing signs that Antarctica, for example, is undergoing changes in ice mass loss that are ahead of schedule that had been predicted in the models. I've seen a myth from denialists that the climate models have been really inaccurate and the whole thing is a hoax. Well, I can tell you the biggest inaccuracy in the climate models was under predicting the rate of sea ice melt in the Arctic. Now, when ice melts on the Arctic Ocean, it's like an ice cube melting in your glass. That doesn't raise the level of the sea. But when ice melts on Greenland, which is land, and flows into the ocean, that does raise sea level. However, even where just sea ice melts, that allows more blue water to absorb more solar energy to allow the water to expand and rise further. So it's not inconsequential. And last week, Secretary of State Pompeo talked about the potential for new sea routes through the Arctic that could benefit maritime commerce for several nations, ours included. But he wouldn't sign an agreement which included the phrase climate change in it, which is a purely political statement to make, and refused to sign that. That's not science. That is denial of science, and that's not going to get us anywhere. We stand alone. We really do, which is a sad statement for the most advanced nation scientifically to take that kind of a pose as is currently taken. Hopefully, we will, at the top level, start to come to our senses as time goes along. So this is a primer, and this site is updated at least every month. It is a wonderful resource if you're a teacher. It's a great tool for your classes, especially at the high school level. And again, the scientists who write the articles here do try to keep the articles at a level where it's not scientists talking to scientists, it's scientists talking to the general population, the interested population, and includes some potential partial solutions to deal with what's occurring in the way of this mean global warming. As I said, I don't like climate change because to me that's a cop out. There's no negative impacts that are being observed globally from global cooling. The climate is not changing in that direction. It is changing toward warmer, not on every square inch of the globe, but when you add all the means together, it is mean global warming. So, if you don't mind, I'm going to stick in my Buffalo News articles and elsewhere with mean global warming climate because there's a lack of clarity in that vague phrase climate change. So that's enough for today. I'm going to come back to more specifics on this topic both here and in my Buffalo News articles. Although some of those are about weather and some are about climate, you can't walk away from this topic because it is ongoing and will be ongoing long after we're gone, long after our children are gone. There's no quick fix. If we were to magically reduce CO2 emissions drastically in the space of a year or two, which can't happen, it would still take a long time for that to have a real impact on the rate of sea level rise, for example, because of the shelf life of CO2 in the atmosphere. But if we don't do anything, and if we head toward the worst case scenarios, which are well modeled and not at all doubtful, they're just possibly too pessimistic. If those were to occur, the effects on human civilization as well as the animal and plant world would be cataclysmic. So it's our job to try to figure out the most cost effective ways to slow the warming process. The politics I'm going to stay away from. It's unfortunate that a number of people do take political stands which in the scientific community are not included in the data assimilation. The data is what the data is, and most good scientists are able to filter their own personal ideologies out of the data and just be scientists. That's our job, me at the lower level and the major research scientists, of course, at a much higher level. So, hope you've sat through this. No one nodding off out there, I hope. I thought I heard some snoring in Sloan. Anyway, I'll talk to you soon.